Building modules for a legacy CMS often means battling constant friction. Developers spend hours writing repetitive procedural logic, the boilerplate code, required just to make a basic module function. The daily routine involves executing the same mechanical tasks, manually generating URLs, resolving file paths, and typing out repetitive security sanitization. Like a heavy gear system, the development process stalls under the weight of its own repetition. This repetition breeds specific anti-patterns across the codebase. You find raw string concatenation used to build links, deeply nested ternary operators checking if variables exist, and the HTML special characters function manually applied to every single output string. When a developer sees the exact same block of validation code 50 times in a single file, they stop reading it. Code reviewers develop structural blindness, making it easy for a single missed character or missing syntax to slip into production. Maintaining the sheer volume of boilerplate consumes the engineering hours meant for feature development. More critically, it creates an environment where human error becomes a systemic vector built directly into the application. XOOPS Helpers is a utility library built for PHP 8.2 and later, explicitly designed to dismantle these legacy patterns and modernize the developer experience. It replaces deeply nested manual logic with convention-driven facades. These facades act as simplified, testable interfaces that handle complex system operations behind the scenes. Integrating it requires a single composer require command. It is a standalone dependency. There are no configuration files to write, no bootstrap modifications to make, and no service providers to register. This moves development away from a procedural mindset, where a developer manually checks and routes data at every step. Instead, the library introduces fluent primitives, allowing data to be chained and transformed continuously. By embedding the correct logic into the tools themselves, the codebase moves towards an architecture that is secure and reliable by design. Extracting data from deep, multidimensional arrays in legacy PHP presents an immediate structural problem. Developers are forced to write nested if statements or array key exists checks at every level to prevent the compiler from throwing runtime warnings. The library resolves this through the R utility class, which standardizes array manipulation. Look at this syntax comparison. The legacy approach requires a verbose ternary operator confirming data exists. On the right, r.get accomplishes the same logic in a single line. Dot notation abstracts traversal logic. Missing keys safely return a fallback value, removing complex nested branching. This array wrapper also unlocks advanced data shaping capabilities. Instantly isolate columns with pluck, categorize datasets with group by, or collapse multi-level arrays using flatten. Abstracting these array primitives clears the visual clutter from the file. When a developer reads the code, they see the true intent of the data structure rather than the mechanical steps required to extract it. In legacy XOOPS modules, the most common cause of malformed file paths is manual string concatenation, relying on the global XOOPS root path constant. Hard-coding paths this way creates inconsistent environments. You end up with mixed forward and backward slashes, missing directory separators between folders, and unencoded query strings that break unexpectedly. The manual concatenation on the left is replaced by the path and URL facades. These automatically normalize separators, trim duplicate slashes, and securely encode arrays. Standardizing these operations eliminates between 25 and 50 individual lines of concatenation in every module. Because these URL generators operate globally, they work the same way in a background cron job as they do inside a specific module's execution context. Pushing path generation behind a unified API removes the cognitive load of tracking trailing slashes across different host operating systems. The legacy view layer relies on a critical security assumption that developers will remember to manually wrap every single piece of user-provided data in an HTML special cares function. This approach is fragile. A single oversight, forgetting a function call just once, creates a critical vulnerability, allowing malicious scripts to execute directly in the browser. The HTML builder class replaces manual view escaping with systemic enforcement. As shown, when raw data is passed into HTML builder.attributes or classes, it is intercepted. The structural gateway automatically applies context-aware escaping before constructing the final HTML output. This removes the need for developers to manually memorize or type complex security flags for secure rendering. Security at scale is achieved by making the safe execution path the default code to write. This introduces a central architectural tension. How do you build a modern API that integrates deeply with legacy XOOPS constants while ensuring that the new code remains completely independently testable? The solution is a 5-tier architecture where dependencies flow exclusively downward. At the foundation is Tier 0, pure PHP utility classes completely isolated from the CMS, executable anywhere. Moving up the stack, Tier 2 service facades bridge these modern APIs to the legacy environment. In a production environment, these facades automatically bind themselves to legacy constants, like XOOPS URL. However, these exact same facades can be seamlessly overridden during execution by calling a simple .use method. This override mechanism enables global free mocking. Injecting a mock clock or fake path into the facade allows the entire test suite to run instantly. Strict dependency stratification means developers can write modern, cleanly decoupled logic while operating entirely inside a legacy environment. With the introduction of the new XMF 2.0 framework, it is vital to understand where XOOPS helpers fits into the broader ecosystem. The operational boundary is defined by scope. XOOPS helpers is limited to low-level day-to-day data manipulation primitives like strings, numbers, and arrays. This chart highlights the contrast. Helpers handles data on the left, while XMF 2.0 operates high-level architecture on the right, managing states, executing tasks, and wiring dependencies. They don't compete. XMF 2.0 declares helpers as a foundational dependency for low-level operations. Maintaining these strict domain boundaries prevents framework bloat. It guarantees that each library remains lightweight and focused on its specific tier of operation. The ultimate realization of these fluent primitives is the introduction of data transformation pipelines. Raw data passes directly into a pipeline, sequentially chaining through independent formatting functions to return as a clean, structured object, eliminating intermediate variables. Adopting this library immediately adds over 150 automated tests and 40 source files of battle-tested utilities to any module. This entire modernization payload deploys without requiring a single bootstrap file or configuration schema to activate. Standardizing these operations removes the friction that slows down legacy maintenance. By offloading fundamental data manipulation and security escaping to a dedicated utility layer, engineers can finally stop writing boilerplate and focus entirely on building core business logic.